Hi everyone, this is my continuation video to the previous one. In last session we discussed about realization of FIR and IIR filters with suitable structures and system function, and also we discussed basic elements of the block diagram to represent the FIR and IIR filters in a block diagrammatic representation like direct form 1, direct form 2, cascade and parallel structures. So how these structures will be derived means, yesterday last session we discussed about the system function, and now we are trying to form that system function into different possible forms, and depending on the form it will be named as the direct form 1, direct form 2, cascade form or parallel structure. Now we will see the system function and how that system function will be arranged into various forms, and what will be the name of that structure is given. So first we see system function mathematical representation. H of z is equal to y of z by x of z. So this will be equal to sigma bk, k equal to 0 to m, sigma k equal to 0 to m bk z power minus k by 1 plus sigma k equal to 1 to n ak z power minus k. So this is the system function representation, and now we will arrange this equation into different possible forms. They form the direct form 1, form 2, cascade and cascade structures. So first we will expand this function. H of z is equal to, by expansion, b power 0 b0 plus b1 z power minus 1 plus b2 z power minus 2 plus and so on plus bm z power minus m divided by 1 plus a1 z power minus 1 plus a2 z power minus 2 plus and so on plus an z power minus n. Now first we see, and you know h of z is equal to y of z by x of z. First we see direct form 1 realization. What will be this system function h of z will be arranged in the direct form 1. Next we see the direct form 2. So first we will discuss about direct form 1. So in direct form 1, treat this as the main equation 1, and let's do cross multiplication. So y of z into 1 plus a1 z power minus 1 plus a2 z power minus 2 plus and so on plus an z power minus n is equal to x of z into b0 plus b1 z power minus 1 plus b2 z power minus 2 plus and so on plus bm z power minus m. So while doing the cross multiplication we got this equation. Next multiply with the y of z and x of z. So y of z plus a1 z power minus 1 y of z plus a2 z power minus 2 y of z plus and so on plus an z power minus n y of z equal to b naught into x of z plus b1 z power minus 1 into x of z plus b2 z power minus 2 x of z plus and so on plus bm z power minus m x of z. Okay, so this is the equation. From this, finally write the equation for y of z. So finally equation for y of z is equal to, so right side is same, b naught x of z plus b1 z power minus 1 x of z plus b2 z power minus 2 x of z plus and so on plus bm z power minus m x of z, and left side terms, take these left side terms to the right side, so it becomes minus a1 z power minus 1 y of z minus a2 z power minus 2 y of z minus and so on minus an z power minus n y of z. So this is the final equation in the direct form 1. So now we will represent this equation into the block diagram representation, and this formation is called direct form 1 structure. Now we will see the how that direct form 1 structure will be implemented. So it is, if you understand this direct form 1 structure, then direct form 2 structure will be very easy to understand. So first please be concentrate on the direct form 1 realization. So once we are thorough with direct form 1 realization, direct form 2 will be easy, and similarly you can easily construct the parallel form and cascade form also. So please all of you look at this, how I implementing this direct form 1 equation in the block diagrammatic manner. So here if you observe here, the parameters we can see input signal x of z and output signal y of z, and b0 b1 and so on bm, a1 a2 minus an and so on, those are the constant multipliers. And also you can find z power minus 1 z power minus 2 z power minus m. Okay, those terms are known as the unit delay elements. Already we discussed about basic elements of the block diagram representation in the previous video. So here exactly you can observe whatever the terms or whatever the parameters we have seen in the last session means basic elements of the block diagram. So exactly those elements here. Now using those elements we will construct the direct form 1 structure. So for that, first at the input side, for the input side x of z input side signal, and let us take at the output side y of z at the output side signal. So for convenience, I start developing the direct form 1 structure at the output end. So first, if you look at this main equation, let us say this equation will be 2 y of z equal to, first consider the terms related to y of z. So minus a1 z power minus 1 y of z minus a2 z power minus 2 y of z minus an z power minus n y of z. So first consider the terms associated with y of z, and we will finish that structure. Next we will go to the terms including the x of z. So first if you take this term minus a1 z power minus 1 y of z. So y of z signal is there, and z power minus n unit delay element is there, and minus a1 constant multiplier is there. So first we consider these terms and we will construct the partial block. So similarly we follow the same procedure for constructing the remaining blocks also. So this is the signal y of z, and so this is also y of z signal, and here first mention the constant unit delay element z power minus 1, and so here now the output will be z power minus 1 y of z, and what is the missing parameter here? Constant multiplier, and that constant multiplier is minus a1. So minus a1 should be represented like this, and now here the output signal is now minus a1 z power minus 1 y of z. And next, what is the second term? Minus a2 z power minus 2 y of z. So extend this, and here you will get unit delay element z power minus 1 only. Next, here the output will be z power minus 2 y of z. Z power minus 2 y of z. Now the output at this stage z power minus 2 y of z, and the missing value is minus a2 constant multiplier. So mention that minus a2, and you know the output will be minus a2 z power minus 2 y of z, and so on. And so on. You can draw the as many stages you want, z power minus 3 y of z into minus a3, so like that. And now, so this will be, and so on, and here one more z power minus 1 will be there. Finally the constant multiplier will be minus an. So here you can write minus an, and here z power minus 2 minus 3 and so on. So here you will get z power minus n y of z, and you know here the output will be minus an z power minus n y of z. And if you look at this, all the terms to be added, so I am adding all the terms. So this is the stage at output and gets finished. Next, look at the terms associated with the input signal x of z. So whatever the procedure I followed at the output, and same procedure I follow at the input side also, to construct the each block, and finally all the blocks to be added, and finally it forms the direct form 1 structure. So if you look at this, b0 into x of z plus b1 z power minus 1 x of z. So for convenience I follow from the second term, and at the end I will include the first term also. Then you can feel comfortable by for constructing the direct form 1 structure. So b1 z power minus 1 x of z. So you know this is the x of z signal, and here you are supposed to write z power minus 1, and you know output of this signal is z power minus 1 x of z, and here constant multiplier should be b1, and constant so first constant multiplier should be b1, and here the output is z power minus 1 x of z, and here b1 z power minus 1 x of z. Next, similarly construct the second term, z power minus 1 constant multiplier will be b2, and output will be b2 z power minus 2 x of z, and so on, as we have followed in the output end. Same procedure here I am following. So here finally z power minus 1, and here if you observe this, final is bm, and here bm z power minus z power minus n bm z power minus m x of z. So as we have drawn at the output end all the terms to be added, and here one term we have missed, that is, see, b naught x of z is there. So this is x of z, and here mention the constant multiplier b naught. Now at this output is b naught x of z. So all these terms to be added. So it forms the direct form 1 structure. So here simple block by block you can construct at the output end, and same follow at the input end, and add input end side and output end side. Finally it gives you the direct form 1 structure. In next our video we will see how to construct the direct form 2 structure, and then parallel structure and cascading structure. Once you are thorough with direct form 1 and form 2, cascade structures and parallel structures will become very easy, and parallel and cascade forms will be implemented by using either of the two forms, that is direct form 1 and form 2. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.